So today we're going to talk about completing the square. Now, it's not the quickest way to solve a quadratic equation, but I would use factoring or just plug it into the quadratic formula first, just from my experience in pre-calculus. But this is just another handy way to solve a quadratic equation when you don't really feel like using the quadratic formula and you're just like, I can't factor this. So what this video is going to cover is I'm going to first go through how to solve any generic quadratic equation using completing the square. And then I'm going to show you a little bit of a geometric proof on why completing the square works. And then I'm going to go through a couple examples. So first and foremost, if we start off with our generic quadratic equation, ax squared plus bx plus c equals 0. What we got to do is we got to isolate these x terms, like these terms with x. All right? And to do that, we just need to subtract both sides by c. So we get ax squared plus bx equals negative c. Now, to make completing the square easier, what we have to do is we have to get rid of this term in front of x squared. So we divide it through by a, so that we can ensure that the coefficient in front of x squared is 1 and 1 only. All right, so here we go. We have x squared plus b over ax equal to c over a. So now that we have it looking like this, the essence of completing the square is we want to write this as x plus some term squared equal to negative c over a plus that term squared. All right? And so now you're probably wondering, okay, how do we get that term? Well, it might make more sense in the geometric proof that I'm going to do a little bit later in this video. But how you would find this value is you would divide this b over a coefficient, this middle coefficient, by 2. So your final thing that you do when you complete the square is you get x plus b over 2a squared. And then you have to add b over 2a squared to the other side. And I'm going to show you really quick why. So when you expand this, x plus b over 2a squared, what you're going to find, and then I'm just going to expand it here and save space. I'm just going to blot out that squared sign there. Get x plus b over 2a times x plus b over 2a, and you just expand this. So you get x squared plus b over 2ax plus b over 2ax plus b over 2a squared. What you can see is we get x squared plus b over ax, because 1/2 b over a plus 1/2 b over a equals b over a, x plus b over 2a squared. So now when you put it like this, you get this extra term, b over 2a squared, and so thus you have to, oops, I didn't put the parentheses there, you have to add this extra b over 2a squared to the other side to compensate for this new term being created, right? You can't just add random extra stuff over here and not do anything over here. So this thing right here compensates for this. So that's kind of the general overview about completing the square. So now I'm going to show you the geometric proof, and if this doesn't make sense, don't worry. It will hopefully by the end of this video. This is just the really general version, and we're just going to get more and more specific, and we're going to back it up with more concrete looking examples. Alright, so let's say we finally isolated this term x squared plus b over ax equals some random term like negative c over a. Now, what we can do is we can factor this expression right here into x plus b over a. And we can express it in like a geometric fashion. So let's say we have these rectangles right here, right? And we can label this side length x, and this is x plus b over a. And the area of these papers represents the given area of this function when you multiply x by x plus b over a. When we're completing the square, what we're doing is we're making this area that this function creates into a square. Now, what we'll do is we're going to cut this b over a in half, like this. And so now what we have is you have these two thin strips that are half as big. So what we do is we multiply this term by half. And since this is half BA wide as well, by x, we can say this is half times b over a. And so this final term over here is going to be half BA by half BA, which is b over 2a squared. And since this wasn't part of the original area over here, we have to then add this on that right side of the equation. So sometimes, maybe this might not make sense, but for some people who like to think about things a little bit more visually, this is something that may help. So now we're going to go on to some examples. So let's say you want to solve x squared plus 8x minus 9 equals 0 using the method of completing the square. Now, as a reminder, completing the square isn't always the fastest. You can also solve this by factoring. So x plus 9, x minus 1 equals 0 is an equivalent expression. So we know that x is equal to negative 9 and x is equal to positive 1. Now, why am I solving it using a different method ahead of time before I actually do this? Well, I want to show you that completing the square method actually works. And so what we're going to be doing is we're going to use the method of completing the square to solve this. So to complete the square, what we're going to do is we're going to add 9 to both sides. So now we're left with x squared plus 8x equals 9. Now, you probably remember at the beginning of the video when we had ax squared plus bx plus c, is that we divided a through by all these terms here. But the thing is a is equal to 1, so dividing everything by 1, everything's the same. So we now can move on to our next step. So what we do is we divide this middle term by 2. So we get x plus 4 squared. And we're going to set that equal to 9. And because of the fact that we get this extra 4 squared term in here, we need to also add 4 squared to the other side of the equation. So now I'm just going to simplify a couple things real quick. And so this is equal to 16, and 16 plus 9 is equal to 25. So now what we want to do is we want to get rid of this squared. So we can just take the square root like this. And you're left with x plus 4 is equal to positive or negative 5. And so we can subtract 4 from both sides. And what we're left with is x is equal to negative 4 plus or minus 5. So x is equal to 1, which becomes negative 4 plus 5. And x is equal to negative 9 because negative 4 minus 5 is negative 9. And so that's how you would use the completing the square method to solve this problem. So here are your solutions. And you can see that these solutions are identical to those solutions. Before I close this video, I want to make one final point about completing the square. You can never, ever, ever use the method of completing the square if you have a function that looks like this, where you're missing the bx term, or you have a function that looks like this. Using the method of completing the square is a big no-no in these cases. You have to have an ax squared component and a bx component. So these two right down here are the only two ways a quadratic equation can look if you want to use the method of completing the square. So you can see here, this is equal to 0. 0 can be any constant. So if this was equal to 4, it would be fine too. But you have to have an ax squared, and you have to have a bx in order to complete the square. Thank you. Hope that helps. And if you have any questions, just write a comment below.